Okay, so first things first is the goal today. And maybe I should start with my name. And the date, 9/9. And this is third hour. Okay, so our goal today is going to be to evaluate and simplify algebraic expressions. So, an algebraic expression. Oh, no, a variable. A variable is a symbol. It's often a letter that represents a number. And I think a lot of these terms probably look familiar to you. Does that sound accurate? Like, give me a 1 through 5. I'm pretty sure I've seen all of these. I don't remember what they are, but I've seen them. Down to a 1. Never have seen any of this in my life. What is life? Just kidding. Okay. An algebraic expression and a variable expression, these are the same thing. Okay. So we'll group those together. It's just an expression that contains variables. When you're being asked to evaluate something, all you're being asked to do is use the order of operations to simplify an expression down to a single value. And that's something that you guys actually did in your 1.1 assignment when you had to simplify or to evaluate. So evaluating, you're just going to follow order of operations, which probably a lot of you think of PEMDAS as soon as we do that. Do we remember PEMDAS? So are we okay if we don't write it out? Parentheses, exponents, multiplication, division, addition, subtraction. Does that sound okay? All right. Then a term, there are going to be multiple terms, okay? So it just depends. Like in this expression right here, there are 1, 2, 3 terms. It's what's separated by the addition or subtraction signs. So 3a is a term. Technically, negative 2b is a term. 4ab is a term. So there are 3 terms there. Okay. So a term is a number, a variable, or product. Product means that you're multiplying a couple things together. Separated by either a plus or a minus sign. So either adding or subtracting. And then the coefficient is just going to be the numerical factor in a term. So it's the number that's usually in front of a variable. That's your coefficient. So it's the number in front of the variable. So to evaluate this expression here, it tells us that a is going to be 1. So everywhere there's an a, I'm going to put a 1. Everywhere there's a b, I'm going to put a 2. I'm sorry, negative 2. So then we just have to fill everything in. So 3 times the a minus 2 times the b plus 4 times a times b. I like to go through and write the whole thing with parentheses. and then go back and plug in everything I need to. Because a lot of times people will accidentally miss a subtraction sign if there's a subtraction and a negative sign. So you want to make sure you don't miss anything. So I write everything out without the variables. And then I go through and I say, okay, all the A's are going to be 1. So this is now a 1. This is a 1. The B's are going to be -2. So this is a -2. This is a -2. And then I go and I simplify from there using PEMDAS. So parentheses come first. There's nothing inside any of these parentheses that can be simplified any further. There are no exponents, so I'm good there. I can move on to multiplication. This multiplies here to 3. This is going to multiply to, technically that's -2 times -2, so +4. This is going to be 4 times 1 is 4. And this goes back to those properties we talked about yesterday, where it doesn't matter the order you multiply these 3 numbers in. Pick 2, multiplying them, multiply by that third number. So 4 times 1 is 4, times -2 is going to be -8, so -8. Okay. 3 plus 4 is 7. 7 minus 8 is -1. Give me like a 1 through 5 on how I did that. 5, I could do that on my own. Down to a 1. Whoa. Where are we? All right, cool. All right, same thing with the next one. The next one just has an exponent in it. And I wanted to show you how we're going to put the parentheses. You want to make sure that the parentheses are just around the variable itself. So -3, we have parentheses, and then it's squared. Okay, the exponent's going to be outside. +4 times, there's your x, -1. Anywhere there's an x, we're going to put -2. Now, it's really important that you have parentheses here, because if you didn't, this will be wrong. Okay, if you square -2 and it doesn't have parentheses, I'm going to write it over here. -2 squared is actually -4. Okay, but if I take -2 and put it inside parentheses, that is actually going to be +4. So if you fail to put parentheses, you will get the wrong answer there. Because the way that PEMDAS says that you have to evaluate this, it says you have to do the exponent first. So 2 squared is 4, and then apply that negative. Because that's what the order of operations says to do. But here, if you're applying the square to -2, now you're doing -2 times -2, which is a +4. So there is a difference there, and you got to make sure that you are using parentheses. Okay, so first thing that we're going to do is we can simplify inside parentheses. So -2 minus 1 is going to be -3. You can also take care of that exponent. It's part of a separate term, so you can do it at the same time. Okay. We took care of parentheses and exponents. Next comes multiplication. -3 times 4 is -12. We're going to get the same thing over here. And we're adding -12 to -12, which is -24. Are we doing okay? Awesome. I'm going to go ahead and flip. If we are being asked to simplify, you get it down to the smallest number of terms possible, meaning if you can combine like terms, that's what you're going to do. So that's all simplifying is combining like terms. So like terms have to have the exact same variables in it. So in this case, your 4x and your 7x are going to be like terms. So we're going to get 4x and 7x is 11x minus the 2y, which can't combine with anything else. Does that look familiar? Give me like a 1 to 5. Totally remember doing that. Okay, cool. All right, so this next one, it's a little bit trickier because there are so many variables within each of those terms. What I like to do is I put everything in alphabetical order because that's just my weird OCD. But it also allows for you to recognize the like terms a little bit better. So if I rewrite this, 4x squared y, x and y were already alphabetical. Plus this next one, I'm going to write it as 7xy squared. Notice the squared goes with the y, so y squared has to be y squared still, but I can rearrange it. So instead of, because really right now I have yx, I just put the x out front, so it was xyy, and wrote it like this. Because multiplication, order doesn't matter, and that's what you guys learned with the commutative property. Okay. Plus the last one, I can write it as 2x squared y. Does that look okay with how I rewrote things? Okay. So the reason why we do that is because now it's a little bit easier, whereas the 4x squared y and the 2yx squared didn't look like they were like terms. If you put them alphabetically, now they match. Okay, it's a little bit easier to see that this and this are like terms because they both have x squared y on them. So then when we combine those like terms, we have 6x squared y plus 7xy squared. And part of simplifying is also you put the highest degree, is what we call it, first. And degree just means how many variables are in there. And in that case, since that's actually xxy, this would have a degree of 3. This one is xyy, also has a degree of 3. So it doesn't matter the order that you put those two terms in. But in some cases, if the degree is higher, you want to have the highest degree out front in order from highest to lowest. Okay. I don't think you'll see any of that in the assignment today, but we eventually will get there. Okay. Finding the perimeter, there's a couple ways you can go about this one. You can find the length of each side and add it all up, or you can figure out that the perimeter is 3x plus 4x plus 1 plus 6x, which would be 3, 4, 5, 6, 7, 8, 8 and 6. We're at what? 14x plus 1. So you can add it up first. Do you want me to explain or show where I got that from? Are we okay with that? So I can do it like that and then actually take and say, okay, now plug in x is 7. I believe that's 98 plus 1, so it ends up being 99. So you can do it that way, or you can say, okay, 3 times 7, this side's 21, this side is 7, this one's going to be 29, this side would be 42, and then add up those 4 numbers. And if we take and add up those 4 numbers, 21, 7, 29, 42, we also get 99. So it doesn't matter which route you go. You can find all 4 sides, then add them. Or you can simplify that expression first and then go from there. Okay. Evaluating this last one, you guys did see some absolute values in your assignment yesterday. So there's, you're going to see some more today. All you're going to do here is, do we know the definition of the absolute value? What is an absolute value? It's not necessarily the opposite. Go ahead.
They're not negatives.
They're never negative, yeah. Does anyone know why, like what that proper definition is? It's because an absolute value is the distance away from 0. And a distance is always going to be positive. So when you're talking about distance, it's always going to be positive. So whether you were looking at -5 or 5, the distance is still going to be 5 away from 0. Okay, so whether the number is positive or negative, you just make it positive. That's why it's not necessarily the opposite, because if it's positive, you don't make it negative. You just always make it positive. Okay. So 2 times this is negative 3 minus 4. Okay, so I think I have everything filled in there. Now, absolute value bars are like really strong parentheses, okay? So when we're simplifying this, you want to simplify everything on the inside of those brackets first. So in this case, you'd have negative 6 minus 4, negative 9 plus 7. Okay. This one is negative 6 minus 4 is negative 10. Negative 2. Okay. And once you get it down to a single number, you don't just get rid of those bars, okay? You actually have to think about what is the absolute value of negative 10? What is the absolute value of negative 10? 10, positive 10. Okay, we have a subtraction sign in the middle. That has to stay there. That was not inside absolute value bars or anything, so it is what it is. Okay, what is the absolute value of negative 2? Positive 2. What's 10 minus 2? 8. So our final answer here is going to be 8. Okay. Now, I'm going to show you one more problem just because I want you to see it. If I had something like this, okay, 3 minus, or it's the absolute value of 3 minus the absolute value of negative 6. Okay, what's the absolute value of 3? It's still going to be positive. It's still going to be 3. I still have that subtraction sign. What's the absolute value of negative 6? What's 3 minus 6? Negative 3. Is that okay to have a negative answer when I was dealing with absolute values? Yes. Because I wasn't taking absolute value of the whole thing. I had absolute values in there, but it was still subtraction, which created a negative number in the end. And that's okay. So that is possible that you'd have something like that. So that's just what I wanted to point out.